Welcome back. We're talking about another reference design today. This one about the DC power monitor designed by Mike. Mike, what's going on behind this DC power monitor? Because I do remember a different power monitor in the past.
Yeah, so you may have seen the video that we did on the AC power monitor, and the applications for that, maybe like you're in a machine shop or you're monitoring like household power. But of course, there is that whole other universe that is rapidly becoming popular, which is direct current, and that's because of electric vehicles and batteries. And so, one of the use cases that you could see for a power monitor would be like a bike rental charging station. If you have those electric bikes around your city that have a kiosk of like 5 bikes, if you had monitoring when they were plugged in, you could tell a lot about that battery, like how far that bike may have been driven, what the health of the battery on the bike is, and helps you do some preventive maintenance and helps you kind of spec out what's going on with your entire fleet.
Right. Yeah, I think that's a really good example there, and also one where you'd want to have cellular, which this design also has. So let's talk a little bit about the AC with the other one, and this one's DC. So what did it take to transform this? Because they sound like they're totally different, but they maybe aren't that different under the hood.
Yeah, so the nice thing is we kept most of the platform the same. And so, like you said, it's got that Nordic NRF 9160 cell modem as the base of it, but we swapped out the sensors. So before we had some analog to digital converters, which were monitoring a current clamp that would clamp around one of the legs of the AC power. DC is just fundamentally measured differently. And so we pulled in a new chip that specializes in measuring DC power, and it gives us really easy readings through I squared C to, let's see, what are they? Voltage, current, and power.
That's right. Yeah. Yeah. It's actually called a VCP clip just because of that voltage current power. There you go. Yeah. It sticks out to me because, I mean, so we use this thing that we call Aludel, this kind of like prototyping platform we built up, but it literally was like a snap in kind of thing. And then you just had to like write some different sensor driver code, right?
Yeah, and actually, this is kind of like eating your own dog food. So we've been working on these
Yeah.
reference designs as a way to like quick start our customer projects, so that customers that come in and need something, we can give this to them. It's not exactly maybe the hardware they want or not exactly the functions that they want, but it's like 70 to 90% there, and then they can swap out a different sensor or do something with a different function. So we started with the AC power monitor that had like all the firmware going there, and even connections online and the way it was being visualized. Like we copied all of that stuff, and all we did was swap out and write a new sensor driver, and then do a little bit of like glue logic, because the readings are not quite the same for AC as they are for DC. But generally speaking, that everything was done for us, and it made it pretty good, which is nice because we were getting this one ready for the Embedded World Conference.
I was gonna say there were some
Yeah,
practical implications here too, which
yeah,
was we didn't want to mess with 240 at a conference at a conference in Europe where all power is 240, 230 really, 230,
yeah.
240, and so DC kind of made a lot more sense just for making it more portable too. We actually
Yeah, I
have it
mean, we
here. This,
talked about
yeah,
it.
yeah,
The thing
right,
is, like, we could have had a remote device when you're out at like customer meetings at the conference and been like, look at our conference booth and like how much AC power it's
sure,
using. But you would have had to build a board and isolate it, and like
yeah.
it was involved. So DC came about.
Right. And this is also the reason why, even though Mike designed this is why I have it, because we took it to a conference. Now it's here on my bench. We plugged in some different things. I have a NRF 9160 development board on the left side here. And I borrowed my daughter's light up thing, like a little Starfield light up thing, because it has a bunch of different settings that I can set here remotely. So we can take a look as we're doing this sort of thing. So you see, Mike, tell us a little bit about the demo backing board itself though, too.
Yeah, so Chris's idea was, how do you show off these IoT devices at a conference? And one of the things is there's only so many staff there to talk to people, so you want to have a lot of information. So you can see our standardized, what we're calling the Aludel Mini, is the black case there with the e-paper display on it that tells you what's going on with the readings, on top of a piece of acrylic that's in a frame, and down at the bottom, two plugs for USB. These are channel 0 and channel 1 that are coming up live on the device.
That's right. Yeah. And so we can actually view these live. Let me pull up my screen here. Here. There we go. So we can actually see these things going live as we go. So this is the display. We have a couple different live monitors and then some cumulative as well, like you had on the AC power monitor. People may recall from the last video when Mike was baking a pretzel instead and running this vacuum cleaner.
Yeah, like I said, we just copied from that and changed things out a little bit. Some of the really nice things is we're just passing raw values for these, and then we're using Grafana, which is the dashboard software, to do the actual calculation based on the data sheet of the sensor. That's kind of a nice way to go because it takes some of the computation off of the device itself and lets you do it on the cloud. Plus, if you are finding that you need to calibrate some devices, having the raw readings allows you to do that sort of thing.
Yeah, that's great. That's great. I'm trying to turn this on. Oh, there it goes. Turn it on right now too. I was actually surprised, like one of these things is like, it becomes so, oh, it's playing music in the background too. Let me turn off the music. I didn't realize that this thing's drawing, so I had this thing just kind of plugged in the wall normally. It's drawing 20 milliamps, right, on just like Vampire current, and because it's ready to turn on. It's got background processing there, and like I learned that immediately from plugging in here as well. You can see this little spiky here. That was actually me turning the sound back off, so I can turn on different functions here. This is a multi-function kind of thing. I could change up the lights that it has. I'm not sure if it's coming through on the video, but I can add multiple LEDs here. Obviously more current for more LEDs. I think that's all. There you go. There's all the LEDs. So this is the maximum current it would draw now. It does have a motor going as well. And it is smoothing out like some of the instantaneous stuff. So it's not showing. So this is taking your reading, what I think every 5 seconds or so, and sending it back to the cloud. It's not going to have like the spikiest readings that you might, if it's something like the dev board on the left side, the channel 0 is instantaneous current it's drawing there. You might not see when it's trying to reach the cell network, which would be a very spiky current thing. You need a higher, more precise thing for that, more resolution in your readings. But for something like LEDs like this, or like you're charging a bike, like Mike said, it really does kind of show you cumulative energy, because you can rely on having this relatively consistent power for something like LEDs and drawing over time.
Yeah, and I think one of the interesting things when you start to look at reference designs and the power of reference designs is we design some things in here that you might not immediately think about. So for instance, it is a cellular application, and so we set up the ability to cache your readings and send them all in one packet when you get signal again. And especially when we were showing off the GPS reference design, this is a great use case because you might have something out of cellular reach, and the GPS has really precise timing on it. You can timestamp your data that way. But another one is, you mentioned the vampiric power on this. So like the 20 milliamps that it's always drawing even when it's doing nothing. We're recording like cumulative on time for the device. So you can be like, how often is this running? You don't want to include that 20 milliamp level as on time. And so you can actually use the Goliath settings service to set the threshold at which the device doesn't consider what's plugged into it as being on or off.
Yeah, let me make this text a little bit bigger here. So it's going to look a little wonky, just going to try to make it very easily readable on the screen here. But we do have the settings here, and this is what Mike is talking about, the ADC floor. This is basically removing that from the cumulative calculations. Is that right?
Yeah, that's right. And I've just put a raw reading here because just some transient like electromagnetic waves can sometimes register like a 0.01 milliamp reading on these chips. And so I put the floor in there so that it would read 0 when it's actually 0. But if you have like a high load, low load sort of application, you really only want to know when does it go into overdrive on this device. You would set this here, and then you'd have a better count of when you're really utilizing a lot of power.
And like on the AC as well, you're tracking the cumulative in LightDB state. This is one of our database solutions on a device. So if you want to track this stuff, so basically we have this reading that's being published to the cloud as a stateful element here. So channel 0, channel 1, and then like you said, the setting service is basically has some logic on the device whether or not to include the latest reading into that cumulative.
Yeah, and with that setting service, I always like to think about it being fleet-wide as well. So if you have, one of these on every charging dock for the bikes in your city, and you put some new bikes out, and the like resting level changes a little bit, you'd be able to change all of them in one shot, or drill down granularly to each individual device.
Yeah, that's great. That's great. And then we also have, of course, have our sensor. This is the instantaneous stuff being sent back. Also, what's being displayed on the Astentis front panel screen that you can kind of see here in the. Let's see if we can get that. There we go. So on that, if it's readable, hopefully, some of the lighting stuff on my webcam It's not super great for that, but yeah, you can see the instantaneous readings here as well, and that's able to read that stuff back there.
Yeah, I mean, it's the thing is, it's not very, a lot of these use cases aren't very flashy, and that's part of the problem.
Yeah.
But like, there's real power. There is a lot of business to be done with figuring out what stuff is using electricity and like drilling down to why that is. Definitely when we were using the AC and hooking up to the house and saying, wow, look at all the energy that's being used by this device, even when it's not in use, is very interesting. But I also do think as we get power walls on our houses and we get more cars being charged at home and in businesses, we're going to see a lot more use cases where like DC battery monitoring is going to be huge. And I think there's already an industry standing up around it, but I think it's relatively small still. And it's a great place for IoT to be applied, especially with devices that are mobile.
That's great. Well, let's see one last flashy thing here. I'd see how fast this thing responds when I turn off the light. Let's see, this should drop back down. And then I think that's about it. There we go. So pretty zippy in terms of the responsiveness. So 5 seconds on the readings being sent back to the cloud, and then we're immediately kind of showing it here. So in terms of responsiveness, being able to see that sort of thing, it's really can be super useful, like Mike said, especially as more and more things get electrified in the home, outside the home, in industry as well. Anything else we should know about these designs and how people might be able to use it in their own, as a template basically for their own products?
Well, definitely. I think you should go and take a look at all the information that we have published over at projects.goliath.io. You can try these out on your own devices. We are unwrapping them to be used with the NRF 9160 DK. The one that we were showing is kind of like a custom rolled board. I mean, it's the same radio module that's inside of there, but you can buy these sensors. We're using click sensors. Try out the code yourself. We have a free dev tier. If you want to give Goliath a try, you can go to console.goliath.io. And of course, our front page is goliath.io.
All right. Thanks, Mike. We're looking forward to the next reference design.
Yeah, it shouldn't be long. See you then.